welcome. So before getting into some more kind of new material, I wanted to go through a certain number of examples for you of some more kind of, at the same time, basic and mildly tricky kinds of antiderivatives and indefinite integrals. Well, and actually also definite integrals. So let's just kind of get started. And I'm going to do this in 2 videos because basically to have room on the board. Okay, so here's the first one that I want to do. And what I'm going to want to do is I'm going to want to integrate. So I'm going to take the integral of, and I have 5x squared minus pi x, and then I have plus e squared dx. Okay, so this kind of has multiple tricky things in it. In addition, just to the fact that I showed you how to integrate a single term in a polynomial, but I didn't kind of show you how to do it when it has multiple terms. So that's kind of one thing that we're focusing on. Another thing is that there are some tricky constants in here, right? So notice that these, right, these are actually constants. Okay, so this and this are actually constants. Right, they're just numbers. And this is one of every calculus professor's favorite thing to do to try to trick you on an exam. Okay, these are just numbers, and so this is actually just a polynomial. It's a quadratic polynomial. And so the first thing that we can do with this, right, is we can use our linearity. Okay, so let's go ahead and use our linearity. And we're going to write, so we can pull out the constants and break apart the addition, not multiplication, but addition. So I can pull this out and I can go 5 times the integral of x squared dx. I can pull out the minus pi times the integral of x dx. And then last I can put, that one can just go on its own in there, so plus the integral of e squared dx. Okay, so to go here, I just use linearity. That was all I used there. And now I can just use my power rule, right? So I'm going to get that this is going to equal 5 times, and then I have the, so this is a power 2 there, and actually I'm going to put in, just so that it'll make it easier to remember how to use the power rule, this x here is the same thing as x to the 1. So what I'm going to get here is I'm going to get x to the, so this is a power 2, 2 plus 1, divided by 2 plus 1. Okay, and then from this one, so now I do minus, and then a pi. How did I do this in here? Oh, I actually put the constants. Let's just be a little consistent here. I put the constants for that. Okay, so that's the entire indefinite integral there. And then I have minus pi times, and then so I have x to the 1 plus 1, so we're no longer subtracting 1, we're adding 1. And then we'll put a second constant. I'm just calling these by numbers just so that we can see they don't, that they're kind of separate entities. And then we're going to combine them all together in the end anyway. And then for the last one, for this one, I just put, because that's a constant, I know it gets a little funny in our heads, we just multiply it by x, and then put a C3. Okay. So what I just did here was to integrate. So that was where I actually integrated. And then in the next step, what I want to do is I'm just going to remember how I did all these together. But actually, maybe before I even go to the next step, we can kind of figure out what everything is here. So this is a 3, right? This is a 3. This is a 2. The benefit of having multiple colors is sometimes you can do multiple things in one step without getting confused. Okay, so then in the next one, I'm just going to distribute this out. And so I'm going to get 5 times x cubed over 3, right, from here. So I'm going to get 5 times x cubed over 3 plus 5 times c1 minus pi times x squared over 2 minus pi times C2. And then I can go plus. And then I'm kind of mildly unhappy with this. I'm going to switch the the color is going to change a little bit. But this, yeah. Okay, so then I'm going to go, and then I just have e2x plus C3. See, this one's a little brighter. Then that's going to be a little easier for you to see. So this is like a pi. I felt like the other one was fresher, and so I thought it would work better, but the yellow, like, it's clear, doesn't show up nearly as well. Okay. But as you're doing this, you can look at the next step here that I want to do is I want to take, I'm going to get slightly obsessive about wanting to finish this line in the brighter color. Okay. Right, so now at this step, what can we do? So one of the things that can happen, right, is I can kind of group together the constants. So I can group together the constants. So there's a constant, here's a constant. It stays a constant when you multiply by another constant, or when you add constants. Multiplying and adding constants gives you constants, okay? So I can group the constants. Okay, and then the other thing I can do, right, is that having this divided by 3 here, that really means I'm multiplying by 1/3, so I can have 5 times 1/3. So I can kind of bring that together too, and just make this a little bit nicer, so I get that this is going to equal 5/3 x cubed. That constant's going to be grouped at the end. I get minus pi. Again, this is the same thing, so dividing by 2 is the same thing as multiplying by 1/2, so I can take pi times 1/2 is the same thing as pi over 2. X squared. And then I have plus e squared x plus c. And I didn't forget the c, and the c is just the combination of all the constants. Okay? So there. So I'm done with that. So what did I kind of do? The first important observation here was that the minus pi and the e squared are constants, so we can treat those like constants in using linearity. So we're actually going to do that where we can pull constants out, and we can separate when we have addition or subtraction in here, we can separate it out. In order to integrate, we're going to want to use the power rule, and so I might want to put a 1 on my x so that I remember that that's actually x to the first. And then I have so 5, and then now we're not differentiating anymore, we're integrating, and so we add 1 to that, and then we divide by whatever this is. And then we're going to group together our constants at the end, so we don't worry about that. So x to the 1 plus 1 divided by 1 plus 1. Here, you could think of it as having x to the 0. That would be one way to think of it. Or you can think that anytime you have a constant in there, you just multiply by x. You can think of that as a special circumstance. And then we just group together the constants. One thing that we did was we remembered that like dividing by 3 is the same thing as multiplying by 1/3. So I could kind of see this as 5 times 1/3 times x to the third, so that, right, this is 5 times 1/3 times x to the third. So I can actually write it as 5 times 1/3, which is 5/3 x to the third. Okay. So I hope that made a little bit of sense. And then we'll try another one. And we grouped all the constants together at the end. That's something else to be aware of. Okay, so we'll do one more in this video, and then we'll make a second video to do 2 more after that. Okay, so now the next one I want to do here is to find the antiderivative. So find the antiderivative. So find the general antiderivative, but I'll just write find antiderivative of, and then I want to do g of t equals and I have the square root of t, and then I have plus t to the minus 3. And then the last thing I have there is plus 1 over the square root of t. Okay, and the first thing here, so there are kind of two things I'm highlighting here, maybe two kind of mildly tricky parts. The first thing is just that I'm using t instead. That shouldn't bother you. Hopefully by now that's less bothersome to you. It does help to write these in a form where it's easier to use the power rule. Okay, so this one we can always think of as t to the 1/2. And this one over here, well, it's t to the 1/2 is on the bottom, so this is t to the minus 1/2. Okay, and then we have the t to the minus 3. And now I'm going to shift back to having, I'm going to use this one again actually. So to find this general antiderivative, so let's go ahead and start. So I'm going to get, so for t to the 1/2, so I'm just going to do kind of like I did before, where I'm going to have, so I have t to the 1/2 plus 1 divided by 1/2 plus 1, right? And then from here, so then I have plus, and then I have t to the minus 3 plus 1 divided by minus 3 plus 1. And then we're going to have, for this one here, so I'm going to have plus, and then we have t to the minus 1/2 plus 1 divided by minus 1/2 plus 1. We're actually looking for the generalized antiderivative, so I'm going to put a plus c here. Okay, and then what I'm going to want to write is that now it can be nice. So what are each of these? So maybe we can even kind of work that a little bit separately here. So this here is the same thing as 3/2. This here is the same thing as minus 2. And here is the same thing as 1/2. Okay, well, what happens when we divide by that? So this is the, so this, by the way, this is my antiderivative. It's good to label what you're doing so that you don't get lost in what you're doing. Okay, so I have here t to the, so this is 3/2 divided by 3/2 plus, and then I have t squared to the minus 2 divided by minus 2 plus, so I have t to the 1/2 divided by 1/2 plus c. Okay, so these are equal. Now, if I have 3/2 on the bottom, I can flip that up, right? So this is actually going to equal 2/3, right? When you bring it up to the top, you flip it over. You just have to remember that. So we get 2/3 times t to the, but we keep that power 3/2. There's, right? That's on, A, it's on the top, and B, it's a power. So if I wanted to move it between top and bottom, I do a sign. If I want to move a fraction between top and bottom, I have to flip it over. If I want to move a power between top and bottom, I have to swap the sign on it. Okay, and we're going to do that in this one. So in this one, so now we have minus 1/2. But this one is actually, we would like kind of to see that on the bottom. So we'll go ahead and put that there. So that's going to be t squared. And then we have a similar thing here. So we have plus 2. And then t to the 1/2. Often we kind of prefer to write that as the square root of t. So we'll go ahead and do that here. Plus c. And then I double check that I got the same thing when I did work in private as when I did it here, because it can always be a little bit confusing. I wrote it in a slightly different form if you see it on the notes, but this is the same thing. Okay, so what were kind of the tricky parts here, or what did we do here? So we have the, a lot of what was tricky here actually was just the fact that we needed to translate these into power so that we could just add 1 and divide by that power plus 1. So we did that. The other kind of tricky things to remember is that when you're moving fractions between the top and the bottom, you need to flip them over. And when you're moving powers between the top and the bottom, you need to change the sign. And we did do that here. I wanted to move that to the bottom, so I got rid of the minus sign. And we did kind of this over here too, because I wanted to move it to the top, so I put in a minus sign there. Okay. And then we just do the same thing where we're integrating and not differentiating. So we add 1 to the power, and then we divide by that power plus 1. And we do that all the way through, and we don't forget our c. Okay. So I hope these are helpful. And then I'm going to do one more lecture of them. And so I'll see you there.